Hey guys, welcome back. Let's take a look at balancing equations. One of the first things that we need to know is why do we have to balance equations? Why do we go through the trouble of these calculations? Well, the law of conservation of mass is the reason. We must have the same amount of molecules on each side of the equation. So if we have reactant A and reactant B, we should have product A and B respectively. They can be different combinations, but not different numbers. You can think of the arrow as an equal sign. Here is an example. H2 plus O2 equals H2O. When we examine this, we can see that there are two H's, two O's on this side, two H's, but only one O on this side. It is not balanced. There should be the same number of atoms or molecules on each side. So we can fix this by putting a 2 in front. This is the coefficient, which will change the number of oxygens and give us 2. But it also changes the number of hydrogens. So then we have to go and change the number of hydrogens in the other part where the reactants were. So that our total number is 2H2 plus O2 equals 2H2O. Let's talk about some rules for balancing equations. Number 1, we're going to balance free metals or elements first. So any free metal or element that's appearing by itself at any point in the equation, we're going to look at first. Next, we're going to choose metals or other elements that may be a part of some kind of compound in the equation. The other thing we're going to look at is polyatomic ions. We're going to treat polyatomic ions as a whole unit. You may remember them from the naming section. They have multiple atoms in the ions, but we're not going to count all those atoms. We're just going to treat them as individual units. We'll also be talking about hydrogen and oxygen, but they will be at the very last. We will wait till the very last for hydrogen and oxygen. Hydrogen we will always do before oxygen. One will take care of the other. Let's look at some example equations. N2H2 is going to create ammonia, NH3. Let's take a look at the non-hydrogen elements. We have nitrogen by itself also, so it counts as a free element. We can see that there's a 2 in front of it, and there's only a 1 on the other side. So I put the coefficient in the front to give me 2 nitrogens. That changes my number of hydrogens, so then I need another coefficient in front of hydrogen to make it the same number. So I end up with N2 plus 3H2 creates 2 ammonia. Here's another example using some of the polyatomic ions that we talked about. Calcium sulfate, and then we have iron chloride. The result is they're going to switch partners, and we'll end up with calcium chloride and iron sulfate. Notice here again we have a sulfate, so it is polyatomic, so we want to treat it as a singular unit. So I'm going to find a metal. We'll just take calcium, And if we look on both sides, we can clearly see that there's the same number of calcium, no worries. But there's 1 iron and there's 2 iron on the other side. So we're going to put a 2 in front of iron to balance it out. But that affects our number of chlorines. So then we're going to go to the other side and balance out the chlorines. But that changes our number of calciums. So then we're going to go over back to the reactants and change the number of calciums. And in doing this, we actually ended up balancing the polyatomic ion sulfate. So now you can see there's 3 of them, 3 calciums. There's 3 sulfates on the other side, 2 irons, 3 calciums on that side, and we still have 2 irons on this side. So we're all balanced up. So the final equation would be 3 calcium sulfate plus 2 iron chloride, resulting in 3 calcium chloride and 1 iron sulfate. That's all for now. See you next time. Bye-bye.